So we see both for convex and concave. I think some echo is coming. So we look for still okay. We look for both convex and concave. Okay. So first case. Okay, just note down. Okay, case 1. Case 1. Ray parallel to the principal axis. Okay, this is the first case. Ray parallel to the principal axis. So let's say, now let's take this one. So let's say consider this is the coating inside. Then this is which one? Which mirror? Concave, right? So this is what? Pole, yeah. This is principal axis. So let's say take this one as C. What is C? So F will be in the middle of the C and P. F will be in the middle of C and P, right? So let's say if you take a ray which is parallel to the principal axis. So what will happen to this ray? It will pass through the focus. Okay, it will pass through the focus. So this is the known thing, right? So whichever the parallel ray will always pass through the focus. Let's say this one also pass through the focus. So the ray which is parallel to the principal axis, it will always pass through the focus. So now how we draw the normal? Sorry. So we'll draw a line from center to the point of incidence, right? It will give the normal. So this will be theta. So this will be theta. Okay. So this is in the case of, this is concave mirror. So let's take in the case of convex. Okay, for the convex. This is what mirror? So this one, principal axis, right? So let's say this one is C. Take it as C. This one will be F. Okay. So if you extend this one this side, now we are passing the ray which is parallel to the principal axis. So it must pass through the focus, right? So it will appear like it is coming from the focus. Okay, it will appear like it is coming from the focus. It is diverging from the focus. Okay. So how to draw the normal for this one? Yeah, from the center. Here. So this will be theta. This will be theta. So this will be I. This will be R. I will be angle of incidence. R will be angle of reflectance. So this diagram is clear, right? So this is the case one where the ray is parallel to the principal axis. So for both concave and convex. Now let's take case 2. Okay, this is convex mirror. Now let's take case 2. So the ray which is passing through the principal axis of a concave mirror directed towards the principal axis convex mirror after reflection will emerge parallel to it. Okay. Yeah. Focus, then it will be parallel. So it's just like a case 1, but opposite to the in the sense like that. So not opposite to the case 1, but it's a dual. It's called dual. Okay, dual. Okay. So always you need to represent the this reflection coating. This one will be pole. This one will be principal axis. Okay. So now we are saying, so this is, let's say first always C and F. Now if a ray is passing through the principal focus, means take any ray. Any ray which is passing through the principal focus will be parallel to the principal axis. Okay, clear, Rohit? So now how to draw the normal here? C to the point of incidence. Okay. So this will be I, this will be R. This will be I, this will be R. Now for the case of convex, for convex coating will be, the reflective coating will be outside, outward. So this will be pole, this will be the principal axis. Let's say this will be C, this will be F. Now we need to consider the ray which must pass through the focus. Means okay. So this must always should be parallel. Parallel to the principal. This is incident ray. This is the reflecting ray. Okay. Now how to draw the normal again here? Same thing, right? Okay. So this will be I. This will be R. So this is in case of concave. This will be for convex. Understood, na? Rohit, clearly? Now case 3. So case 3, we are considering the ray passing through the center of curvature. ray is passing through the center of curvature. Then what will happen? It will again follow the same path. Okay. Why? Because the angle of incidence is 0. Right? Angle of incidence will be 0. This will be pole, right? This will be principal axis. So this will be C, this will be F. Now we are considering the ray which is passing through the it is passing, so the same way it will reflect. Because the angle of incidence is generally how we draw the normal C to this point, right? So the angle of incidence is exactly coinciding with the normal. So the incident ray is exactly coinciding with the normal. So then the angle of incidence is 0. So R will be also 0. So that's why that will again retrace coming back. Okay. So concave mirror. Now let's take a convex. This is the pole, the principal axis. This is C, this is F. This is the principal axis extension. Now we need to take a ray which must pass through the right. So then it will again retrace back. Convex mirror. Understood case 3? Now let's go to case 4. So case 4 is directly meeting at the pole. So the point of incidence is at pole. So then the ray incident obliquely to the principal axis towards the point pole. And the concave mirror or a convex mirror is reflected of same with the same angle. So obliquely means like, so let's say this is the concave mirror. So this is pole. Okay. So now this is let's say C. This is F. The same way it will reflect. This is R. So in this case, normal will be principal axis itself. Normal is principal axis itself. Okay. Now it's a concave. So always in the ray diagram, you need to keep the rays properly. Incidence means going. Reflective means we need to keep perfectly the arrows. Okay, understood, Rohit? So now take a case of convex. Now coating is towards reflective coating is towards outside, right? So this is the pole. This is the principal axis. This is C. This is F. Now, if it is coming like this, means it will. This is incident. This is reflected. This is I, this is R. Yeah, same as concave. So making equal angles with the principal axis. Making equal angle with the principal axis. Why? Because normal is the principal axis. Very good. Okay, understood? So you understood these 4 cases. So what is the first case? Parallel to the principal axis passes through the, in case of concave mirror. In case of convex, it will appear like diverging from the focus. So what is the second case? Parallel to the principal axis. Concave mirror. So it will be parallel only. Okay. Okay, parallel. Same case, parallel. Right? Next one. Retrace back. Yeah. So it traces back. Not appears to be retraces back, but we need to join properly like this. Right? So fourth one will be same for both concave and convex. So it will make with the same angle with the principal axis, because your principal axis is normal. So these are the 4 cases. Now we see the image formation by concave mirror. Image formation by, these are very important. Okay. Image formation by concave mirror. Yeah, Rohit? Image formation by concave mirror. So if you understand these things, it would be very, very nice. Okay, very easy. So no difficulty. Okay. So first case, so here we consider total 6 cases. How many cases? 6 cases. So case 1. Case 1, let's consider the object is at infinity. So here we are seeing the image formation, right? So image formation means there should be object. Then only we can see the image, no? So in the first case, we are considering object is at infinity. Infinity means all the rays will come in parallel. Infinity means all the rays will come in parallel. Sorry? Why can't it be? Slanting in the sense, yeah, it can be slanting also, but always they will come in a parallel. It can be slanting also, but always they come in a parallel. Okay. But here we consider that, so these rays are parallel to the principal axis. Okay, that case. Because here we are considering all the objects, they are perpendicular to the principal axis, no? So here also, if object is perpendicular to the principal axis, means rays will come parallel to the principal axis. Because in all cases we are considering the object is perpendicular to the principal axis. So that's why in this case also perpendicular to the principal axis. Perpendicular means they will come parallel to the principal axis. Okay. So good question, Rohit. Okay. So case 1. So now here we see for only concave. Next we see for convex. First concave. So that's why here concave we mentioned, no? For concave, right? So now case 1. Good question, Rohit. Okay. Case 1, concave. Just assume coating is inside. Okay, concave. So what is this one? Pole. This one is principal axis. So we are considering the rays are coming from the infinity, right? So just mark it like something dot dot dot. to show that they are from infinite. So now this is one ray which is parallel to the first of all, once you draw the concave mirror or convex mirror, you need to mark the C and F. C, F and P. These are always must. C, F and P. Okay, these are always must. So now what will happen? So this is coming parallel. It will touch to, it will pass through the right. So if the ray which is coming parallel to the principal axis, again it will retrace back. So then here. So if it is here, then again it will okay. Now this is the point. This is at infinity. Okay, Rohit. So whenever you draw the ray diagram, always you need to mark the arrows properly. So directions properly. This is the direction, means the incoming ray, incident ray. So this is a reflected ray. Okay. So now what's happening with the case one? So it is appearing like a point. Sorry. Right. So now where the image is being formed at the focus. So now it is appearing like a point. Object is appearing like a point, right? So it's a diminished, and it is appearing like a point. Okay. This is for the case one. So what is this one, M and N called? This is aperture. Okay, M and Mn is aperture. So now, so this is the with the infinity case. This also you mark it like a dot dot dot. It says that it is coming from infinity. So now case two. Case two. So now the object is not at infinity, but it is after C. It is not at infinity, but beyond C. Beyond C. Between, very good. Between C to infinity. Between C to infinity, but it's not at infinity. So once we draw the concave mirror, what is the mirror? What we need to mark it? P, principal axis, and C and F. These are must. And also, yeah. Okay. So now we are considering our object is between C and infinity, right? So now take this one. So let's say this is our object. This is our so this one, if the ray is coming, yeah. So this one it will reflect back to the first ray. Second ray will be parallel to the principal axis. What will happen to parallel one? It will pass through the Pass through the focus. Now, when the ray is passing through the center of curvature, it reaches back. So, now this is the image. Got it? Between, good. Between C and F, and it's a inverted diminished. In real inverted diminished. Okay, real inverted diminished. So diminished, real and inverted between F and C. So if it is at infinity, so it is at the focus F, and the highly diminished point sized real and inverted. Okay. So this case understood, na? So let's say we consider this is a B, object is B, image will be B dash. Okay, you need to mark the rays properly. Okay. Clear? Why it is starting from? Means we are locating the point. We are locating this arrow. This is the top point, no? So the down point is at the principal axis only. Okay. So in order to so now this will be vertical, no? So this also will be vertical only. Image will be same vertical only. Okay. So now we are locating this point where this point will appear. So from the same point, many rays will come. From the same point, many rays will come. Let's say if you keep a let's say one light source, like a point source. If I see from here also, I will see the light. If I see from there also, what's happening there? The rays are going everywhere, right or not? So let's say if it's an object, the rays will come and go everywhere. So the ray will go like this also, will go like this also, will go like this also, will go like this also. But we are not interested in all those rays. But we want to find out where the two rays are touching, where the two rays are they are meeting. Okay. So for that we are just saying this point is appearing where that we want to find it out. So then obviously this point will appear here. This point will appear here. This point will appear here. So just if you find out this point, then the remaining points will appear in the middle. So now that's why we are finding out this one here, we are marking it. So once that is done, we'll draw that. Like that, you need to ask questions for it. Okay. So case 2, understood, na? Case 3. So now case 3, object is exactly at the center of curvature. Exactly at the we need to mark pole, principal axis, center of curvature, and F. Clear? Now object is exactly okay. So now also again you need to draw the two rays. One is parallel to the. So what will happen? This will pass through the focus, right? So next way, what way we can consider next way? Very good. Passing through the focus. Passing through. Sorry? Yeah. It folds. So it will appear exactly down with the same size. Okay. So images are formed exactly at the center of curvature at C, same size, real and inverted. Okay, same size, real and inverted. So what are the two more rays? So one is a parallel, will pass through the focus. One more is focus. One is focus, which will become the parallel. Other is which is going to the center of curvature. So here we can't draw that line because exactly the object is at the center of curvature. No? We can't draw it. So that's why we can't use that. So other one is which is passing through the pole. Then it will exactly pass through. So this also you can use. Very good. Any of the four rules we can use. But we may not be able to use some rules there. In particular case, we can use other, any two rays are enough. So all the four are okay, no? All the four rays are okay. Any four rays are easy. So, but basically, once it is parallel, you can draw very easy. Principal axis parallel. So mostly take these cases. Take the case like which is passing through the focus. That will be parallel. That you can easily draw it, right? And which is parallel, it will pass through focus. You can easily draw it. Which is center of curvature. So these three will be easy for you. Case 4. Okay, case 4. Now the object is between C and F. Object is between C and F. So first of all, P and then C and then F. Okay. Now the object is between C and F. So this which is lie on the principal axis will always lie on the principal axis only. So you no need to bother about it. Only you need to consider the tip, where this tip will end. That's why we are only focus on tip. Okay. So now we need to draw the two lines, no? So one is parallel to the principal axis, which will pass through the okay, and one more is which is passing through the center of curvature, or which is passing through the, you can take that also, which is passing through the focus. Okay, it will be parallel. Now here it will be here, so it will be B dash, will be okay. So it will form after the C, beyond C, and it will be inverted, enlarged, right? After beyond C, it is real, inverted, enlarged. Okay. In this case, at C, real, inverted, same size. That thing. Good question. One thing is here. So here to here, same distance. Here to here, same distance. So here the angle is same. So it's keep on increasing. Here also keep on increasing. So the distance that traveled here is more compared to this distance. So obviously then height will be more. So then this height will be more. Got it? So wherever you keep here to here, so here to here, but this distance is more, no? So then it will come down more than this one. So then this height will be more. Got it? So in the previous case, why it is diminished is, so here it's a diminished, right? Now see, so let's consider the ray which is passing through the focus. That will be easy for you. Okay, which is passing through the focus. Sorry? Yeah, right. So now if I consider this one, the length traveled is more here compared to here. So then this height will be less. Understood? So the length here I am traveling is more. Means the same angle means the height will be more compared to here. So let's say if you consider here, so you can see, no, this height is more compared to this height. Then obviously it will be less. Good question. Understood now? So here, why it the same size is? The distance traveled is same, so the same size. Clear? So now case 5. So here what's happening? Case 2. Case 2 is real inverted. It is formed between C and F. Diminished. Right? Here this is again real inverted formed at F, highly diminished, point size. Now case 5. Understood now clearly, Rohit? Any other explanation? Clear now? You should do well, Rohit. Okay. So case 5. Case 5 is now it's exactly at the focus. Exactly at the focus. This is P, C, F. Exactly at the focus. Now let's consider the two rays. It is not applicable for the, yeah. It will applicable parallel to the principal axis. We can draw it, Okay. So, but we are considering the top, no? If I consider this point, it will be difficult. But I'm considering it. Huh? Okay. Okay, Rohit. This is incident. This is reflected. Now, which is other way can I consider? Passing to the center of curvature, passing to the focal point. Now I can consider. I can consider, right? That I can passing to the pole. That I can consider. Right. Consider passing to the pole also, right? Or passing to the center of curvature also. Okay, Rohit. This incident, this is reflected. So here you can see both rays are going parallel. Okay. So then they will meet at infinity. If some two rays are parallel, they will meet at infinity. Okay, at infinity. The image will be formed at infinity. Understood now? This is the reverse case of first one, dual case of first one. An object is in infinity, image is formed at focus. Now the image is focus, then it will be formed at infinity. Okay, here. So at infinity, highly enlarged. So before highly diminished like a point, right? Now it's highly enlarged and real and inverted. So little bit again keep some focus on this and tell me in the next class why they are parallel. So for all these cases we could easily understand, no? Why these are diminished or enlarged, these things we could easily understand. But here exactly why they are parallel. Just take some time once you go to home and see, okay, why they are parallel. Okay. So case 6. Now it's a what's the remaining case now? It is between the F and C, F and P. Okay. This is P. This is C. This is F. Now the object is between F and P. Now consider the ray which is passing through the pole. What will happen to this one? Okay. This is incident. This is reflected. Now the consider the one which is passing through the center of curvature. Okay, it will be diverging. They are not like a seems like converging, they will diverge. So what will happen then? They will meet at a point here. So this one will be so this is a not real, right? It's imaginary. Huh? Sorry. virtual, right? It's a behind the mirror. Okay. Enlarge, virtual, and direct. So till F, the rays will be they seem like focusing at some particular point, but at F, their rays will become parallel. That's why they will meet at the infinity. After F, then they will diverge. Diverge means they will meet behind the mirror. So that's the virtual. Okay. Clear all the cases? So you should not make mistake here. Okay. So it's easy, right? Easy, right? So you see the uses of concave convex mirrors. That is theory only, no? You see, like, once you see it, what is the uses? If you have any doubt, ask. So now we'll see for the convex mirror. Okay, convex mirror, how the image will be formed. So for concave mirror, how many cases are there? For convex, there will be only two. Only two. Okay. Convex mirror, how many cases will be there? Only two cases. First, you need to keep a pole and the principal axis, and then C, and then F. Okay. Now consider the ray which is consider object is at infinity. Okay. Now consider the rays which are parallel to principal axis. They will meet it, appear to diverge from the. Okay. Now if you take a one more, this is incident, again this will be same. Now we consider one more. This is incident, this is. So they will meet it. So this is a virtual. So and so they will meet at focus, right? At focus. Behind the mirror, highly diminished, right? Because it's becoming like a point only, no? And virtual and direct. Highly diminished like a point size, virtual and direct. Now the case 2, anywhere between the from infinity to pole, anywhere. Can it be anywhere? Okay. So in case of that, what is the next case 1? Case 1, case 2. Case 2 will be between infinity and the point pole, between infinity and the pole P. Okay. Now take one. This is P. This is principal axis. This is, let's say, C. This will be exactly in the middle. F will be. So now let's take anywhere. So for one ray, take to the center. Okay, then what will happen? So for virtual only, you keep these dots. Okay. So it will come through again, same. Right? So now the next case, take it like a parallel. Or take it the one which is through the focus. What will happen through the focus one? It will be parallel, right? Parallel only, right? Take a parallel one. Take a parallel ray, then what will happen? It will pass through the, it will appear like coming from the focus. Okay. So now where these two are meeting? Here. Here, right? Then this is the image. B dash. So what will happen? It is now, it is forming between P and F. And it is a diminished. Okay. And then it's a virtual and erect. Why is it diminished? Yeah, between P and F. So now this is a parallel ray. So we are going down, no? So obviously diminished. Yes. So once you go down means obviously diminished. If it is erected means it can be, if it is inverted means it can be diminished or it can be enlarged. But here it's not a inverted, no? It's erect roll. So erect case it will be like a diminished case. So wherever you keep it follows it will be between the P and F with the diminished. So only these two cases. So you try taking anywhere. Try taking anywhere and draw the ray diagram. You will find that image is formed at between P and F with the diminished. Correct? So this is the image formation. Okay. And you see the uses of convex mirror. Clear, na? So what are the two cases for convex mirror? Infinity, focus, highly diminished, like a point size. Between infinity and between infinity to the pole, P and F, which is diminished, and virtual and direct. Understood not today's class? So to next class we see the sign convention and this mirror formula. We'll solve some problems and then we see the refraction. Refraction will be next class. Next class. So once you understand for this one, that will be easy only. Okay. Refraction will be easy only.